To be able to learn how to verify and simplify trigonometric functions, you must first learn the trigonometric identities. There are many trigonometric identities, but we will be focusing on 4 for this lesson. First off is the quotient identities, which is tan theta equals sine theta over cosine theta, and cotangent theta, which is cosine theta over sine theta. We next have our reciprocal identities, which is cosecant theta equals 1 over sine theta, secant theta equals 1 over cosine theta, cotangent theta equals 1 over tan theta, sine theta equals 1 over cosecant theta, cosine theta equals 1 over secant theta, and tan theta equals 1 over cotangent theta. Next, we have our Pythagorean identities, which is sine squared theta plus cosine squared theta equals 1. 1 plus tan squared theta equals secant squared theta, and cotangent theta squared theta plus 1 equals cosecant squared theta. Lastly, we have our even/odd identities, which are sine negative theta equals negative sine theta, tan negative theta equals negative tan theta, cosecant negative theta equals negative cosecant theta, cosine negative theta equals positive cosine theta, cotangent negative theta equals negative cotangent theta, and secant negative theta equals positive secant theta. You do not have to memorize these identities, but please copy them down and keep them in mind. Now we will start simplifying trig expressions. Keep in mind that you should have your trig identities next to you, and also keep in mind that theta and x are interchangeable. So let's start out with this example. Secant x tan squared x plus secant x. Now first we're going to work with tan squared x and change that into secant squared x minus 1 by the use of the Pythagorean identity. All right, so let's write that down. And we are left with secant x, secant squared x minus 1 plus secant x. Now we're going to distribute this way, and we're going to get secant cubed x minus secant x plus secant x. And we're going to these cancel out, and we're left with secant cubed x, which is the answer. The next example is sine x 1 plus cotangent squared x. And we know that 1 plus cotangent squared x is the equivalent to cosecant squared x. So we're going to write sine x cosecant squared x. And we also know that cosecant squared x by the reciprocal identity is 1 over sine squared x. So we can rewrite that now as sine x times 1 over sine squared x. And this is going to cancel out completely. The squared is going to cancel out here, and you're going to be left with 1 over sine x. But that is not all, because you can reverse the reciprocal identity and make 1 over sine x cosecant x, which is your answer. Next, we will move into verifying trig identities. Now, a note before we start is that you can only use one side of the equation when doing these problems. So you cannot use both the left and right side. You must only work on either side. So let's get started. Tan x cosecant x cosine x equals 1. So what can we do to make sure that these end up being the same? Well, tan x you can simplify to sine x over cosine x by the quotient identity. So let's write that. Cosecant x you can simplify to 1 over sine x by the reciprocal identity. So, and cosine x you can just leave the same. Now, you can start to cross things out. So sine x cancels out with sine x over here. Cosine x cancels out with cosine x over here. And you're left with 1 over 1, which equals 1. So 1 equals 1. This was an easy one. Now let's move on to the next example. Cosine squared x plus sine squared x over 1 plus tan squared x equals cosine squared x. Well, first let's start here. because this is the side that has more information. So 1 plus tan squared x can be changed to secant x by Pythagorean's identity. So let's write this out again. Cosine squared x plus sine squared x over secant squared x equals cosine squared x. Now you can look at this. Cosine squared x plus sine squared x by the Pythagorean identity is equal to 1. So 1 over secant squared x equals cosine squared x. Now, if you use the reciprocal identity, you can change 1 over secant squared x to cosine squared x, which equals to cosine squared x. Bravo! Lastly, we will be trying some more examples to really grasp this concept. Feel free to pause this video at any time to try these questions on your own. First, we will be simplifying. So sine negative x over cosecant x plus cosine squared negative x. Let's focus on sine negative x, which will be negative sine x by the even-odd identity. So let's write that. Negative sine x over cosecant x. And by the same identity, cosine squared negative x can just be cosine squared x, because it is made positive. Now let's look at cosecant x. Cosecant x can be changed to 1 over sine x by the reciprocal identity. So negative sine x over 1 over sine x plus cosine squared x. Now let's divide negative sine x by 1 over sine x. So we can use keep change flips. So negative sine x over 1 times sine x over 1 equals negative sine squared x. And your final answer will be cosine squared x minus sine squared x. Now let's try to verify. Sine squared negative x over tan squared x equals cosine squared x. By using the same even-odd identity, we can make sine squared x negative sine squared x, but it would actually be positive. Because it is squared, you would cancel out the negative. So just write sine squared x over, and tangent can be simplified to sine squared x over cosine squared x. So sine squared x over cosine squared x. And remember, we're only working with this one side. So now we have to divide sine squared x by sine squared x over cosine squared x. And we're going to use keep change flip once again. So sine squared x over 1 times cosine squared x over sine squared x. And we're going to cancel out these. And we're going to be left with cosine squared x equals cosine squared x, which is true. JQ! Stop, drop, learn trig to get to the top. Oh, no, that's how trig functions roll. Stop, drop, learn trig to get to the top. Oh, no, that's how trig functions roll. You can simplify, you can verify, you just gotta try. You ain't gonna die, use the trig identities. That's a real trig recipe, this ain't a mystery. You just gotta follow me, quotient teaches you. Tan ain't hard to do, just sine over cosine for you. Conjugate just a flipper, reciprocals are lit. You take it, then flip it, then you take a hit of more math that I spit. Now for triangles, this will take a while. Just gotta sit and smile at the Pythagorean identity file. Unless we take even odd, the sign of the theta, the bod of the trig we're dealing with. Or is it the opposite? This is stuff you can handle. Break it up and dismantle. Make your brain up like a candle, and then you'll know the answer. Next we'll learn to simplify, then a little verify. But now we'll take a break because I'm about to be late. Stop, drop, learn trig to get to the top. Oh, no, that's how trig functions roll. Stop, drop, learn trig to get to the top. Oh, no, that's That's how trig functions roll. Now it's time for real math. Basics are now the past. Let's head out on the path of having an amazing graph. Simplifying's not too bad, and it will make you glad and not at all sad. When you have the answer in the bag, use identities we've learned to be able to burn the unimportant concerns so you can take a turn. You have to cross out, just so you know, don't scream and shout. You can factor all about and replace things with the right spout to verify we're talking. It's not the same as I'm walking, but we'll know you'll be rocking. Just don't throw a sock in. Verify through similarities. Sometimes it is hard to see, just use the identities. The answer when we were screaming, please! Now we almost done, you see? That was fun, cause we already won, doing it out in the sun. Now I say goodbye. Did you learn though? That's right, I made this whole rap through, so you go high and boo-hoo! Stop, drop, learn trick to get to the top. Oh, no, that's how trig functions roll. Stop, drop, learn trick to get to the top. Oh, no, that's how trig functions roll!